Hello, everybody. First, I'm not a public speaker. Most transmitter guys aren't. So I'm going to be referring to notes every so often. And of course, things have moved around here. Every day I noticed, I think they had notes on the PowerPoint the first day. Second day, the computer went away. And today, it's back, but it's the same screen as you got. So we'll work with it. Some parts of the presentation were stolen from Pete's socket. Just the beginning, so if you've been through this several times before with Pete, it should change a little bit farther down. I did steal the template all the way through, and I think Rich might be happy with that considering your shirt, actually. Okay, Cabell Broadcasting is owned by Jim Goodman up there. That's a picture of him in the first HD transition back in 1995. The TV in front of him is actually, I think, a Panasonic monitor that was $13,000 back then and weighed about 120 pounds. We've got 3 call letter stations, 3.2s, 1.3, and we're now channel sharing with Telemundo. We have a web-only clean version and a geo-targeted version. Now, when the mobile handheld project kind of petered out, Pete Socket asked me to attend some meetings at NAB headquarters. They were called fringe meetings. Really interesting stuff. I was the dumbest guy in the room, but I met a whole lot of really interesting people. Some of them are here right now. Really nice folks, and it really opened my eyes to a lot of stuff. Also, how far into the twilight zone real big thinkers can get sometimes. We went way out there. Later, once the committees were formed, Pete divided some of us engineers into areas of specialization. I got the physical layer, since I'm the transmitter guy. Ever since that work started, my dream was to have an experimental station. I thought, hey, I got this spot back in the corner there where it used to be an ATSC 1 experimental rig. Why not put a 3 there? Well, one day, spring of 2016, my dream came true. Be careful what you wish for. They had one condition. We wanted on the air in time for the Olympics. That was 6 weeks later. So with the help of a lot of folks, no one of them up there in the center, a whole lot of folks in the industry pitched in, and believe it or not, we got it done. That's Jimmy Goodman, Mr. G's son. There's a little bit of history there, too. We had kind of a museum going, since that was the room that the original station was in. Let's see if I get this right. Yeah, there it is. That was one of the receivers out of the original field strength truck. That's actually second generation ATSC 1 receiver. And that was our original MPEG-2 encoder. It weighed about 300 pounds, had 4 handles, and I think it drew about 40 amps. Now, where am I? Okay. Now, 39's kind of a low power, just squeezed in between all the adjacents and co-channels, but it does manage to cover Raleigh, Durham, and Chapel Hill pretty well, considering. It's just 2 panels sitting up at about 1,740 feet. Now, that's our first mod cod setup. Joe asked us what we wanted to start out with, and we said, I don't know. And so basically, they gave us an equivalent to ATSC 1, which did really well considering, although we didn't really have much to receive it on at the time. Everything we had in the early production days were kind of mismatched. Some things would work with others, some things just, sometimes. And the thing is, nobody could really tell you what was definitely going to work. You just had to plug it together and see what happens. Oh yeah, if you look at the bottom spec there, I use carrier to noise. Sometimes it's signal to noise. Sorry for the faux pas. It's just consider it the same in my world. Anyway, it's close enough. We survived Rio by the skin of our teeth, basically. It was a real science fair project. But it was neat. It was really neat being early 4K broadcasting. But the link from the network was real interesting to maintain. And 2 years later in Pyeongchang, I can't say it was any easier, but it was a lot more polished. We also went over to AC4, which I think I hit in the next one. Yeah, when we started up this project, ATSC 3 wasn't a standard yet. Matter of fact, it was only probably halfway there. Firmware upgrades were coming in the door once or twice a day for most of this gear. And we learned real quick that when you only have one of each piece, troubleshooting is not easy, because you have no idea where to look, especially if you got no test gear to go with one of each piece. Now for 2018, we added AC4 and tried out some different encoders. You see, the spaghetti has grown at that point. We actually had, I think, 18 people in that room at one time trying to get ready for the next event, which was this demo we ran along with NAB and NBC. What we did is we invited some folks from a local business incubator that we partnered with. We were trying to get them in and interested in developing apps for ATSC 3, because I think that's really a big vacuum that needs to get pushed. Again, thanks to our many industry friends, we pulled it off. Long nights, but we did it. Special thanks to Jay and the guys from Etri for dongles and tablets and gateway, which was really kind of the hit of the show. Also interesting to the folks who were thinking about apps, though, was the NAB pilot interactive demonstration, which basically it was excellent, but is nerve-wracking because it came down to within, I think, 6 or 8 hours of the show before we actually got it completely working. Got to do some plug fests. I didn't go to Shanghai, but I was able to visit Baltimore and help out with Columbia, which was wonderful. I think it was Mark Aiken who said plug fests are kind of like watching paint dry. And I'd agree, except that every once in a while you get a spot where it's really interesting. And you get to network with some really incredible people. My favorite part was the Friday, the last day of the Columbia Plug Fest, where we started playing with stuff. And there's 14 carriers on an SFN. Yeah, this is all in a little MATV system in a room, but that's 14 different carriers on channel, and you're decoding one of them. The other thing that we did just to see if it would work is we managed to get, I think, 52 PLPs in one channel. We didn't go any farther because it was just hurting some people's fingers to punch all the information in. So when we decided to find a test vehicle for ATSC 3, it wanted to be to measure mobile. Unfortunately, like a shiny new truck wasn't in our future. And at WRAL, we believe in recycling. And so we had our choice of numerous trucks. The only thing is the smallest one we had was an E350 one-ton van. And a little cumbersome. You've used them for field strength. We get them all the time coming off of news and rework them for a field strength truck, but as far as mobile goes, it didn't work too good. Fortunately, Zoo was coming offline with promotions. The guys in promotions had built this thing filled it full of TV sets and computers and whiz-bang stereo. Took it out a few times and handed out some t-shirts, and then they were done with it. So when it was coming offline, I said, oh, that's perfect for mobile. You know, at least you can get around, it's nimble, whatever. So we took out the TVs, some of the computers, kept the electrical, and peeled as many of the stickers as we could off. Unfortunately, that paint job was a paint job, and we didn't really feel like sandblasting that off. So now, when I go somewhere, most people ask me if I'm a storm chaser. Now, as I mentioned, zoo is not exactly built for a crowd. It's really built for one person with the software that they run nowadays that you can drive mobile. You can just turn it on and drive around and take your measurements. And it also does fit in the garage. That saucer antenna, once we pulled the preamp out of it, turned out to be almost exactly the same gain as a reference dipole on channel 39. And it's probably the most omni thing I've ever seen. These days, besides trying to survive the repack, we're working with UNC on a project to feed emergency information to first responders, and occasionally we host people who want to test in a real-world situation or want to cross-check when they've been at another one of the test stations and just want to make sure that things agree from one to the other. As far as, you know, we're always happy to test new gear and stuff, but unfortunately, you know, we have day jobs, so sometimes our response time is a little slow for what most people want. We also continue to test the physical layer, which brings me to the other half of the title, basically. That was as many as I could think of off the top of my head, but I'm sure there's more. If you run all those numbers together, if you include the ways that you can divide the subframes up, multiple subframes, vary the frame size from what, 50 milliseconds to 5 seconds or something like that, you'll end up with an incredible number. I think it'd take years to try all of them. So most of our testing has been commuter testing is what I call it. Basically, my ride from the house to work is right out a side lobe. So I can get from full field strength to the fringe in less than 20 minutes. So I'll pick a mod cod, run it a few days, and pick another mod cod, run it a few days, and do like that. You know, we started using LDM as soon as our stuff supported it, but we really wanted to see if it was as much of a free lunch as it looked like it was. So for the comparisons, we kept many of the other selections the same or as close as possible, which is, you know, that's why apples to oranges. Kind of stepping back, this was our first mod cod with 2 PLPs. When we finally got a scheduler, it's TDM and was pretty basic. We set it up to be 16 or to be 16K FFT so that we could run mobile, you know, but with that carrier to noise, it's a little high for that. But unfortunately, we didn't have a receiver that would do mobile, so that didn't do much good. This is what we run today. It's a mobile, what we consider the mobile channel is PLP0. It's a 1080p deinterlaced basically from the 1080i of our air signal. And 4.5 megabits, little uncompressed. We were doing demos all the time. We didn't want any possibility of artifacts showing up and stuff while you're showing this thing off. So both of our bandwidths are pretty high for what we're running. But because Both of these PLPs are because it's LDM, you have to run the same FFT for the core layer and the enhanced layer. So technically, you can receive PLP1, the 4K, at highway speed. You got to be in real strong signal strength with a mod card that's got a carrier to noise that big, but we've done it. If you were backing down and only doing a couple 720s on it or something like that, you could use the enhanced for mobile also, I think. The only thing is, it's got inherently higher signal to noise requirements. So maybe you could do the core layer for handheld and the enhanced layer for vehicular or something like that. Now, to do the TDM part for our experiment, I ran a bunch of different mod cods, and this was as close as I could get. It's 2 FFTs, 16K for the mobile, 32K for the 4K. The 32K FFT at this pilot pattern is going to be about 45 miles an hour maximum speed. 16K is about 95. Yeah, actually, if I had to run TDM only, this is probably be the one I'd use for this particular setup. You know, everybody's different. Whoops, wrong one. Now, this is part of my drive to work. It's a known dead spot. In fact, and if you see on the left is LDM, on the right is the TDM, the two combinations I just showed you. You want to get down to it, my cell phone drops out from about there to there. So I think that says a lot for ATSC 3. Now, did I get it? Yeah, I think so. Okay, sorry. Now, for fixed testing, we used our saucer antenna and a step attenuator to find the point where we got into errors. Then we checked and logged the carrier to noise and logged the amount of attenuation we needed to get to that point. And the mod cod choices we came up with gave us pretty much equivalent performance at a fixed location between the two PLP1s, but gave us a good gain of 4 dB in PLP0, which is the mobile one, like you just saw. Now, we run 6 dB injection on this, which probably with this set of mod cods, you could get away with 5 and still be okay. Now, speaking of LDM, if you're going to work with LDM, this is important. This is out of the recommended practices for ATSC 3's physical layer, and it's basically the injection level needs to be greater than or equal to, and they use an absolute value, which drives me nuts, but that's, you know, something different, to greater than or equal to the signal to noise of the core layer before combining plus 3. So if you, you know, if you had the original core layer carrier to noise was, say, 2 dB, then your injection level has to be more than 5 dB or you get into trouble. What happens is if you get too low, it'll kill the core layer, and if you can't decode the core layer, you can't decode the enhanced layer, so both of them go out at the same time. We're also really paranoid and conservative, so we use the Rayleigh numbers, which tend to be higher for your carrier to noise and stuff like that. And then we turn around and round up to the next dB to be safe. Can you tell I got bit by this one time? Yeah. Now, oops, there it is. So, which one do you want to use? Why not both? There is LTDM and TLDM. We haven't worked with them yet. We want to, but I think that's a bit down the road. They both have some interesting things. I think actually, Jay could probably tell me better. LTDM could be theoretically if you just had 2 PLPs on the core layer. And yeah, so basically, if you do more than 1 PLP on the core layer, you're doing LTDM already. Oh, excuse me. And which mod cod's best for you? Well, it depends, really. What do you want to do? Do you want to do what you're already doing now with the same kind of carrier to noise? That's easy. Do you want to enhance your coverage by dropping your carrier noise down so you can get way out in the fringe? You could do that. You could do both. You can add services, channel sharing, whatever. For us, you know, LDM worked good. The 4 dB improvement was a very good thing. And remember that fringe isn't always out at the edge of your coverage area. It can be on the drive home. It can be in a garage somewhere or in an office building. So what we've learned in this project so far, some of the things we've learned anyway, are if you have the privilege of being the one to set up the physical layer, please read the recommended practices, go try your stuff out, play with the toys, and come back and read the recommended practices again. And for me personally, I'd say print those tables, 4.3 to 4.8, and keep them handy, because management's going to come back to you and say, we want more bits. And you need to be able to tell them, okay, we'll give you more bits, but it's going to cost you this in coverage if you do that. This is a big one coming from a transmitter guy. In the future, buying a new encoder might do better for your coverage than putting 2 transmitters in. Because if you get 3 dB out of your encoding, especially just flatten it out good enough, that's 3 dB better carrier to noise you could do, which is the equivalent of double your power or half your power. A good example of this is the experimental station covers just about out to the edge of our ATSC 1 coverage area with 40 kW. And we run 1,000,000 watts in the primary station. But the big thing there is that's PLP0, which is a carrier to noise of about 4 dB compared to the 17, 18, whatever it is of the ATSC 1. This one, sorry, it's a very old drawing. This is like one of our first setups. But the whole point is, if you're buying an encoder, don't just buy an encoder, look at the packagers and all the other parts, everything going up to the input of the scheduler, because that is where you need to be as flat and level in bit rate as possible. Any change in that bit rate, any variation, if it's bursty or anything like that, you have to set your mod codes up for the highest value of that. So you start wasting bits and wasting money. And one more. This one's obvious, but it's bit me more than once. You can make a brand new machine out of something just by doing a firmware upgrade. So please don't do it if you're in the middle of testing. That's great otherwise. I mean, we've seen some wonderful stuff happen, but when you're really the apples to oranges at that point. And that's it for me.